Hello, this is Alex Eames from RasPiO.tv. So now we're going to have a look at some PWM experiments. What is PWM, I hear you ask? It stands for pulse width modulation. What it basically is switching something on and off really rather quickly. And this is what it looks like. It's kind of like a square wave pulse. So if, for example, something was switched on half of the time and off half of the time, like a light bulb for example, it would be about half as bright as if it was switched on all the time. Now this happens really quickly. So it's a method we can use to actually dim LEDs or control the speed of motors or various other things. There are 6 PWM pins on the Duino and they are all marked with a minus. -3, -5, -6, and then you've got 11 minus, 10 minus, 9 minus. Now the minus, you don't use that in the program, it's just a little mark to identify the pins which can be used for PWM and to make it easy. So what we'll do is we'll do a PWM version of the blink sketch. Let's connect up our LED like we did before. The resistor end goes to pin 5 and the LED end goes to ground like that. And we'll put it on the Pi. Okay, it's still got the flip-flop sketch loaded up from last time, which is why it's flipping and flopping, which is alternating between the two LEDs. What we're going to do is we're going to load up a sketch called Blink PWM, and just this LED will blink between a bright state, between full brightness and between low brightness but not zero brightness. So it will just show you, hopefully you can see it on the video, that you're able to dim an LED using this technique. So let's try it. Okay, so we want to load the sketch. So we go File, Sketchbook, Blink PWM. After a short while it should appear on the screen. So here you've got the sketch at the top, you've just got a comment explaining what it does. Then here we are initializing pin 5 to be our LED variable. Here we're setting it up as an output, much as we've done before. And notice you don't do anything differently, you just set it as an output and the PWM bit comes a little later. So here's our main loop, which is just a few lines, and what it does, we're using our LED variable, which is equal to 5, so it's pin 5. So we're using that, and we're using a new function we haven't done before called analog write. Notice the capital W there, that's important. And we are setting it to 255. That's maximum on, fully on all the time. PWM in Arduino wiring language goes between 0 for fully off and 255 for fully on. And there's continuous flow of integer values in between. So 0, 1, 2, 3, 4, 50, 100, all are integers. So initially we're setting it at fully on, then we are waiting for 1 second, then we are setting it to 50, which is, I don't know, something about 20% on. So it's going to be fairly dim. Then we're waiting for another second, then we hit the end of the loop and it goes round again, and this loop will go on forever. So that's what it does. It basically sets up the pins, sets it fully on for a second, then 20% on for a second, and keeps going on forever. So what you should see is it should be fully bright, then not very bright, then fully bright, then not very bright. Let's upload the sketch and see what happens. So remember, we go File, Upload using Programmer, compiles the sketch, uploads the sketch, done. So can you see that? That's now not going off, it's just going to a low brightness state.
You see, that's what it would look like if it was off. It's just going to a low brightness state. In the next sketch we're going to use a loop to cycle the LED from 0 to 255, which is full brightness. So it's from off to fully on and back down again, and we're going to keep going round and round and round. And we're going to use a loop to do that, and you'll be surprised at how little extra code there is.
So the next sketch is called Blink PWM Loop. So we go File, Sketchbook, Blink PWM Loop. Let's have a look at the code. So at the top we have a comment. This line's the same as last time. We are just setting our LED variable as an integer and making it equal to 5, which is pin 5 for the LED. Now we're setting it up as an output, as we did last time as well. Now let's get on to the main loop. So you'll see that we have two smaller loops. One is starting at 0 and going up to 255 in increments of 1, and the other is starting at 255 and going down to 0 in increments of -1. So what this does is the first half makes it brighter and brighter and brighter and brighter with a 2 millisecond gap in between each increment, and the second half makes it dimmer and dimmer and dimmer and dimmer in the same way with a 2 millisecond delay between steps. So that's what we have. So this is the init. Remember what we did with the loop. We're setting up a variable, brightness, and making it equal to 0. Then we're setting the end point of the loop, which is 255, and the increment, which is the amount that it changes each time the loop goes around. So it's the first time around it starts at 0, then 1, then 2, then 3, and it does that very, very quickly, and you'll see the results. And then in the second half it goes down. So let's upload with File, Upload using Programmer. It's compiling, it's uploading, it's done.
There you can see the LED cycling up and down from 0 to 255 in steps of 1, but it's doing it so fast that we can't tell the difference between the individual steps. So there's only 2 milliseconds time delay between the individual steps. If you wanted to slow it down, you could change that quite easily. If you wanted to, you could combine this with the 3 inputs that we did previously with the flip-flops, and you could have input control of how fast the cycling up and down goes. That's a bonus. I'm not going to do that for you, but that's a little bonus in the manual. It's on page 33 where it suggests that you do that. That's all very well. We've just used one PWM channel, but we've got 6 of them on the Duino. So let's do something a little bit more interesting, a bit more fun. Let's use 3 at once and our 3-color LED. So here we have a 3-color LED. It's got 4 pins. The longest pin is ground. This one, which is next to ground on its own, is red. The other outside one is blue. And this one next to the longest leg is green. So that's red, ground, green and blue. So what we're going to do is we're going to take 3 of our 330 ohm resistors and we're going to wrap around like we did with the single LED and connect it to each of the color legs, not the ground leg, but this one and this one. There's a photograph on page 34 of the manual if in case you're in any doubt. And what you'll end up with is something that looks a bit like this. Okay, I've bent these so that they're in the right order. So then we're going to connect our resistors so that blue is connected to 11, green is connected to 10 and red is connected to 9. So okay, and you also have to make it so that the ground leg of the LED is connected to ground. This is the ground rail here, and there's a socket just there. So we've got blue on 11, green on 10, and red on 9, and you must make sure that none of these wires are touching each other. That's why it's all spread out so much and looks a bit silly. This is a way of doing it on a temporary basis, but if you wanted to do it permanently, you could solder the resistors. You could even solder them using these holes, and you could even put the resistors on the other side of the board. The other thing you could do is if you want to take the circuit off the Duino, is you could use a breadboard and some jumper wires. So now what we're going to do is we're going to use a flip-flop that works all 3 of the pins in turn. So you should get red going from 0 to 255 and back to 0 again, then green, then blue. We should see the full range of the basic channel colours.
So now let's load Blink PWM flip-flop RGB, File, Sketchbook, Blink PWM flip-flop RGB. So at the top you've got the usual comment explaining what's happening. Then we're setting a variable for the time delay. We'll set it at 2 milliseconds. Then here in the setup function, we've made a loop to initialize pins 9, 10 and 11. So that's starting at 9, looping through and stopping at 12 in increments of 1. So that gives us 9, 10 and 11. Each of those is being set up as an output here, and then once those are set up, we go on to the main loop, which is very much like the previous sketch that we did, except we've wrapped another loop around the outside of it so that it does each pin in turn. So it does 9, then it goes up from 0 to 255 and back down again, wraps round again, does pin 10, so the next one here, then it does that 0 to 255 and back down again, finishes the loop and wraps round and does 11. And then it'll keep going around and round in the main loop. It'll keep going around and round and doing that forever. So let's upload it. File, upload using programmer.
Uploading.
And we're done.
There you go, you can see that alternating between the 3 colours. Let's just dim the lights and maybe you'll see them better. One thing you'll probably notice is that red isn't as strong as the others, and I think that's just to do with the way the LEDs are made. So now we've done that, I know what you're going to ask me. How do I do the colour fading ball, mixing the colours? Right, well there's a sketch for that as well, and we leave the circuit exactly as we have for the previous experiment. If you want to put a diffuser over it, a ping pong ball with a hole in makes a perfect diffuser. I usually put a bit of blue tack on to hold it, or sorry, white tack on to hold it in place, but I'm not sure if that's going to be appropriate this time. So we'll turn it so that the markings on the ball aren't shown, and we'll find the sketch. It's called Crossfade.
File, Sketchbook, Crossfade. And as usual, file, upload using programmer. Uploading now.
And now if I just move that, you should see a cross-fading coloured ball. I think I'm going to dim the lights. And that's really it for PWM. You can also use it for controlling motors if you have a motor controller chip that you'd like to use with that as well. But you've learnt the basics of how to control the PWM pins, and also a fairly advanced colour crossfading sketch, which I downloaded from the internet. I don't completely understand the maths behind all of that and how exactly it works, but that's the point, you don't always need to. So that's pretty much all you need to know about how to program the PWM pins on your RasPiO Duino. In the next video we'll cover use of the analog inputs. This was Alex Eames for RasPi.tv. Thank you for watching.